everyone, welcome to the video lecture series of operating system. In today's session, we are continuing with the topic process synchronization. Myself Kunal Panchal, your instructor. In this particular session, we are going to discuss reader-writer problem, which is nothing but a classical problem of process synchronization. How we can resolve this problem with the help of semaphore that we are going to discuss in this particular session. So let us discuss first what the problem is, and once you understood what is the problem, then we will discuss how we can resolve this problem with the help of semaphore. So as far as reader-writer problem is concerned, as I told you, it is a classical process synchronization problem. When we are talking about multi-programming in which more than one process are ready for execution, and they are waiting for resources for execution. So in the case of reader-writer problem, let us discuss that problem with the help of this particular figure, in which we have a document. A shared document we have, which is a shared text file we have, and that would be considered as a critical section. What it means? So we have already understood what is critical section in the previous scenario. So critical section is nothing but a section of code in a process in which that process is trying to use shared resources. So when we are talking about shared resources, in that case this synchronization is required. When you are using your private resources, in that case synchronization is not required. So let us consider this document as a critical section. And these shared documents are trying to use two process simultaneously. One is reader process and second one is writer process. So if you recall the concept of database, specifically in transaction chapter, we already understood the read operation, read-write operation, write-write operation we have. But out of these three type of operation, let us discuss first one, read operation, because these set of operations are relevant with this reader-writer problem. So we need to understand the problem first, then we are going to discuss how we can solve that problem with the help of semaphore. So as far as read operation is concerned, means if multiple read operations performed on a same document, in that case there is no issue. Like say for example, if I am delivering a lecture and if I am writing something on the board, at the same time multiple students can read, there is no issue. Means multiple read can be performed simultaneously. It won't lead to inconsistency. Yes, so when we are talking about read operation, in that case there is no issue. But second case is what? Read-write, means a shared document can be accessed by two processes. One is trying to read something in it, and one is trying to write something in it. So in that case, if these two type of operation wants to perform at the same time by using the same document, in that case it may lead to a inconsistency. In that case, we need to take care of the process synchronization. In that case, the process synchronization will come into the picture. Yes, because one is reading something at the same time. If write operation is allowed, in that case, read operation definitely will read inconsistent result at the end. So these two operations, read-write operation, is not allowed to perform simultaneously because it leads to inconsistency. Third operation we have discuss write operation. Means if two write process or say two write operation performed simultaneously by using the same document, okay, again it will lead to an inconsistency, because if one is, suppose if we have one a variable and value of a variable is initialized by 10, and if I'm one process is trying to increment the value of value of a, and same at the same time another process is trying to decrement the value of a. So definitely one is trying to increment and one is trying to decrement the value of a. So these two operations cannot be performed simultaneously, otherwise it will lead to inconsistency. So when we have multiple reads, in that case no problem, but when we have one read and one write, or we say when we have both write operation, in that case we need to take care. It should not lead to inconsistency. So how to resolve this problem, okay, which is called as reader-writer problem in process synchronization. So how we can avoid or resolve this issue with the help of semaphore, let us discuss. So first of all we will discuss the writer code, okay, and writer code we will understand with the help of semaphore. And you know very well, semaphore is nothing but integer variable, okay. And when we are using semaphore for critical section problem, that semaphore value would be initialized by 1 always, okay. So that thing you have to keep in your mind, because in this case we are trying to solve the critical section problem with the help of semaphore. So definitely the value of semaphore would be initialized by 1. Okay, so in this case WRT is nothing but one semaphore, right? WRT stands for right. Okay, and it is nothing but semaphore for right operation, and its value is initialized by 1. You can see in the figure. Okay, so in this particular box, I have written the code of writer process, okay, in which there are 3 statements. First statement is what? Because we are trying to solve the writer code with the help of semaphore, so definitely semaphore is associated with 2 standard operation. One is wait and second one is signal, that we have already understood in the previous sessions. So those who are directly watch this video, I strongly recommend it to you. If you want to understand this concept very well, you need to visit the earlier video of semaphore first, then you can able to understand this concept. Okay, so wait means what? Wait will simply decrement the value by 1, and signal will simply increment the value by 1. Okay, so what will happen in this case? By writing a writer code, what we need to do is, what things we need to take care in this case. While any write operation is trying to do some write operation in a particular document, in that case we need to take care no other reader, or they say no other writer can allow to enter into critical section. Yes, so we need to achieve mutual exclusion in such a way that only one write, because we are discussing writer code. So if writer is allowed to enter into critical section, at that time no other reader, or they say no other writer can allow into the critical section. So let us discuss how we can solve these issues with the help of this code. So first of all, the WRT semaphore value is initialized with 1, and once you call this weight of WRT, it means we have already understood the value of 1. Initial value of semaphore is 1, so definitely that write process can able to enter into critical section. So it can easily perform wait operation, and it will simply decrement the value by 1. So now the value of WRT is 0. So at this particular time, one writer is entered into a critical section, and now it is doing write operation in the document. Okay, at this particular moment, if context switching is happen, if one reader try to enter into critical section, so at this particular time, definitely it won't perform read operation, because the value of WRT is already 0. So no other write process, or we say no other reader process can enter into a critical section, because already one write process is using critical section, and once it uses this critical section, then it will come out from the critical section and execute the signal operation. And signal of WRT means what? Once one process executed write operation, now once it completed task, then it needs to allow to another process can enter into a critical section and access the shared resource. So that is the reason why last statement we have in writer code is what? Signal of WRT means the value of WRT was 0. Now we are incrementing that value by 1, so that other process can enter into a critical section and access the shared resource. So the writer code is very simple to understand. Yes, because we need to do not bother about the reader and writer. Just we need to write a code, and we don't want to allow any reader or writer process while a particular process already using critical section. So that's why the code is simple. But when we will discuss reader process, okay, or we say reader code to solve the reader writer problem, or we say process synchronization problem with the help of semaphore. In that case, we need to discuss a lot of things. It is somewhat difficult to understand. So let us discuss reader code. So you can see in this particular block, I have written the reader code, in which this code is divided into two portions. One is entry section and second one is exit section. So entry and exit. So entry section is highlighted by the yellow color, okay, on the upper side, and exit section is again highlighted with the same color in the bottom side. Okay, so in this case, what we need to do is, so instead of having a single semaphore, because in writer code we have used only one semaphore, which is the thing called WRT. But in this case, not only WRT, but also we need to require one more semaphore called mutex. You can see WRT we have used already, so same semaphore we are using over here also, but the another semaphore is mutex. So mutex is basically used for synchronization between multiple readers. Okay, because as I told you, multiple readers can simultaneously access the same document. In that case, there is no issue. So if multiple process already entered into a critical section, in that case, synchronization between those readers, we need to have one semaphore, which is nothing but mutex in this case. Okay. Now one more variable we need to use, simple variable, which maintain the count of readers. So one variable we have called read count, which maintain the value of readers. How many readers are there in the critical section? So that count will be maintained in this particular variable. Okay. So as I told you, mutex is nothing but a semaphore is used to provide synchronization between multiple readers. Okay. Now let us discuss this code. So first of all, we will discuss the entry section. So let us focus on entry section, which is highlighted in yellow color at the upper side. Okay, so what will happen in the case of reader code? So as I told you, multiple readers can allow, but once a reader is entered into a critical section, no other writer can allowed to enter into a critical section. So that things you need to keep in your mind. Okay. So by having this understanding, let us take these two semaphore values like mutex and WRT. The initial value mutex is because we are dealing with critical section problem. So definitely mutex value would be initialized by 1, and WRT again it is a semaphore which handles the critical section problem with respect to writer code. So again it is initialized with the help of 1 value. Okay, and at initial time there is no reader or writer enter into critical section at that time. So what is the read count value at initial position? The read count value is 0. Now let us execute this code. First of all, we are talking about entry section. So what will happen? So the reader, suppose if any reader enters, try to enter into critical section to read something. So first of all, what is the first statement? Wait on mutex. So see, the entry code is enclosed with two operations. One is wait and the last one is signal. Means this is nothing but it provides security. Okay, so that other right process cannot enter into a critical section when reader is already entered into a critical section. Yes, so at entry level, this wait and signal will give the security. So wait on mutex, or case wait of mutex means initial value of mutex is 1, so definitely wait operation can be performed, and once it is performed, the value of 1 would be decremented by 1. So now the value would be 0 as far as mutex is concerned. Now the next statement would be executed by the reader process is what? Read count plus means initial value of read count is 0. Now what reader is trying to access enter into critical section. In that case, the first of all, that value would be incremented by 1 because this read count variable is responsible to manage the updated value of readers. Okay, those are trying to access the critical section. So read count plus means what? Now once this statement is executed, the value would be 1 instead of 0. Now the third statement, if this condition is very important because once the first reader is entered into critical section, when first reader is trying to enter into critical section, okay, so that is the responsibility of that reader. No other writer process can enter into critical section. Okay, so this condition tells us if read count is equal to 1. So definitely in this case this condition is satisfied because read count is we have recently incremented the value of read count, so now it is 1. So 1 is equal to 1. Condition is true. Now it will go into the statement. So statement is nothing but wait of WRT. So wait of WRT means so what is the value of WRT? Definitely WRT value, initial value is 1. So wait operation can be performed. Why this statement we are using? Once a reader is entered into a critical section, okay, now no other writer can enter into critical section. So if you want to avoid these things, so definitely you need to execute this statement wait of WRT. So once this statement is executed, when this statement is executed, when first reader is come, means when this condition is satisfied. Yes, so that is the responsibility of first reader to check or to doesn't allow to enter into any other writer process into a critical section. Okay, so once wait on WRT is executed, then the value will be 0. Now the next statement is signal on mutex. once the particular reader enter into critical section, now if any another reader wants to enter into critical section, that it should be allowed. So that's why this signal needs to be executed, so that another reader can enter into critical section. Yes, because if any another reader wants to enter into critical section, the value of mutex needs to be 1. So that's why we are doing signal of mutex. Okay. So now again the value of mutex would be 1. Now the process P1, first process, is entered into critical section. Now it is doing read operation. Okay. Now doing this read operation, if any writer wants to enter into critical section, so definitely it won't enter into critical section, because the wait operation cannot be performed by the writer process, because WRT, writer semaphore's value, is already 0. Yes or no? Okay. Now let us check if any other reader process wants to enter into critical section. In that case it is allowed or not. So again we need to execute the same set of code in entry section. So wait on mutex, definitely mutex value is 1, so it will be 0. Read count plus plus, again it will be incremented by 1. So now the read count would be 2, means what? Second process trying to enter into critical section. Again condition would be checked. If read count is equal to 1, no, condition is not satisfied, so it will come out from the loop or condition. So directly it will execute the signal on mutex. Okay, you need to keep these things in your mind. Wait of WRT will be executed by only first reader. Okay, because at that time this condition is satisfied. Okay, so again it will increment the value of your mutex. So second, now P1 and P2 both readers successfully enter into a critical section. So it means what? Multiple readers can allow? Yes. So we have solved that problem. Yes. Second problem, reader and writer, that cannot be allowed. Once any reader is already entered into a critical section, no writer is allowed. So that we also achieved. Okay. Now we are going to discuss exit part. Now in this exit part, again it is highlighted with the yellow color at the bottom side. Again, in this case, what will happen? In this case, P1 and P2 is already entered into critical section. Now, if any of the process wants to exit from the critical section, so first of all, that process has to execute this statement, wait on mutex. Yes, because the wait on mutex means what? The value of mutex variable. It is not a variable. It is nothing but semaphore. So what was the value of mutex? Yes. So the value was 1. So it will be again 0 when if 1 is going to exit, the simultaneous operation is not allowed. So to avoid this problem, again we are executing exit section. Okay, to provide security, we are enclosing this set of code in between wait and signal. So wait on mutex. So again the value of mutex would be 0. Okay, read count would be decremented again, because in this case we need to do what things? Because two users are already using critical section, and one user want to exit from the critical section, so read count would be decremented. Okay, and now the read count would be decremented by 1, so now the value of read count would be 1. Okay, now if read count is, now again we need to check the condition, because this condition would be checked by whom? The person or the process who is going to exit at the last. Yes, but But in this case, we have one more process already using critical section. So in this case, this condition is not satisfied because the read count value is 1 right now and it is not equal to 0. So the condition is not satisfied, will come out from the loop and signal will be executed. So again it will increment the value of mutex. So now value of mutex is 1. Again it will, the another process wants to exit from the critical section again. So wait on mutex, again value would be 0, then read count would be decremented by 1. Okay, now the read count would be 0. Yes, because there is no other process enter into critical section. So now the condition would be checked if read count is equal to 0. Yes, condition is satisfied. Means what? When this condition is satisfied, when we have the last reader, okay, in the critical section that want to come out from the exit critical section. Okay, so once the last reader try to exit from the critical section, in that case, now the other writers can allow to enter into critical section. Yes, so in this case we need to execute the signal. So now the WIT value becomes 1 instead of 0 because we've executed signal. And then if you want to allow writer enter into a critical section, so definitely the mutex value would be 1. So at last we have executed signal on mutex, again the value of mutex would be 1. So in this way you can solve the classical process synchronization problem called reader-writer problem with the help of semaphore. So I hope it was clear to you. Thanks for watching this video. See you in the next one.